Okay, so EG4, particle is moving in a plane so that at the time t seconds its acceleration is 4I minus 2tj. So in column terms that's going to be 4 over minus 2t. When t equals 3, the velocity of p is 6I meters per second, so that's an initial condition. So I'm already suspecting I'm going to be integrating, and there's another initial condition there relating to the position vector. Find A, the angle between the direction of motion and I when t equals 2. So from the work that we did in projectiles, we should be able to remember that to get direction of motion you need to know its speed, we need to know its velocity in order to find that direction of travel. So I need to find out v, and if we just refer back, although hopefully you can commit this to memory, or you need to commit it to memory, to go from acceleration to velocity, we're traveling in that direction, we need to integrate. So that's going to be the integral of the acceleration function, which is 4 minus 2t dt. So when we integrate that, we get 4t, and underneath the j component will be minus t squared. And then because we've integrated, we have a constant of acceleration that we need to deal with. That sends us back to the question for the context, and it's telling us that when t is 3, the velocity is 6I. So putting that into my expression, the velocity will be 4 lots of 3 minus 3 squared plus AB. 6, 0 equals 12 minus 9 plus AB. So AB would be 6, 0, taking that over. So 6 minus 12 is minus 6, and minus 9 is 9. So therefore, at t equals 3, the expression for v now, so we've used that to work out what the constant is. So our velocity function will be 4t plus a minus t squared plus 9, so 9 minus t squared. We want the angle between the direction of motion and p and I when t is 2. So now we want to know its velocity when t equals 2. So v will be 8 minus 6 is 2, 9 minus 4 is 5. So its velocity, there's my I, there's my j, is going to be 2 horizontally and 5 vertically, and what we want is the angle between the I and the velocity that it's traveling at. So using right angle trig, opposite is 5, adjacent is 2, theta will be arctan of 5 over 2. I need to flick my calculator back into degrees because it was on radians for the previous example. So setup, angle unit, 1 for degrees, shift tan 2.5. So 68 degrees or 68.2 degrees above the I direction. the distance of P from O when T equals 0. So if I take a new piece of paper for that, so going back to my V expression, I've got my 4t minus 6 and 9 minus t squared. So to get the distance, I need to integrate that one more time. So when I integrate that, I get 4t squared over 2, 2t squared, minus 6t, 9t minus t cubed over 3. Once more, I have a constant of integration I need to find. Go back to the context, and I have when t is 3, the position vector is 20i plus 3j. So when t equals 3, those s's I should make into r's, because we're talking about position vector. R will be 23. So 23 equals 9, 18 minus 18, and then 27 minus 27 over 3 plus AB. So 23 equals 0, and that's going to be 27 minus 9, which is 18, plus AB. So AB will be 20 over 3 minus 0 over 18, which is 20 minus 15. Therefore, my displacement function is going to be 2t squared minus 6t plus 20, and 9t minus t cubed over 3 minus 15. And they want the distance of P from O when t equals 0. So when t equals 0, R will be, that will be 0, that will be 0, that will be 20, that will be 0, that will be 0, that will be minus 15. So that is not the distance, but that's the position. So to find the distance, we find the magnitude of that, which is the square root of 20 squared plus minus 15 all squared. So that would be 20 squared plus 15 squared, which is 25 meters. Okay, so maths is the same as AS, it's just we're dealing in 2 dimensions.